Hi all, this is another example of graphing a function using transformations. So we're starting with this shape over here. I'm naming this basic function that we're working with, y equals w of x, aptly named, I would say. The first thing we'd like to do is sketch a graph of y equals w of 2x minus 6. So this is an example right away of needing to be really careful. Looking at this, I think I'm seeing a horizontal compression by 1/2 and a shift to the right 6. But because I have that horizontal shift combined with that horizontal compression, I actually have to do a little factoring before I can be sure of what the shift is. So if I factor the 2 out, I'm going to get w of 2x minus 3. Notice this is all still inside the function. This is all still affecting x. So even though I've separated the 2 from the x with parentheses, the ones that count are the function parentheses. So I was right in saying that this was horizontal compression by 1/2. So I'm going to cut all of my x's in half. And then I'm going to shift to the right by 3. So if I take this whole graph and make it skinnier and then move it to the right 3, it's going to push it over into quadrant 1, maybe all the way. This end is going to go to -5, -2.5, and then over to 1/2. So yeah, all the way into quadrant 1. So for 4a, let's give ourselves room in quadrant 1. Okay, and then if we follow those points, the open circle, if we do shifting last, we're going to do horizontal compression, which will move it to 1/2. I'm sorry, -1/2, 3. And then if we move it right 3, it'll go to +1/2, 1.5, 2.5, 3. So the open circle is at 2.5, 3, or 5/2, 3. The first corner, if we do horizontal compression, it will land at -1, 1, and then we move over 1, 2, 3, it lands at 2, 1. The second corner, -3, 2, when we compress will be -1.5, 2, and then we shift and we get -1/2, +1/2, and 1.5, 2. So 1.5, 2 is another corner. It's 3/2, 2. -4, 1. When I compress, that'll land at -2, 1, and then I shift 1, 2, 3, and it's at 1, 1, final corner. And then the closed circle, -5, that's the one I followed earlier, so it's going to go to -2.5, 3, and then over 1, 2, 3, it lands at 1/2, 3. Closed circle at 1/2, 3. So it was a W, it's still a W, but it is skinnier and moved into quadrant 1. Part B. Part B has definitely a flip over the x-axis. That's flipping my y values. I also have to be careful because I see what appears to be a flip over the y-axis and a shift to the right 3. Because I have horizontal shift combined with another horizontal transformation, I'm going to need to do factoring first. In this case, I just need to factor out the -1, and that turns it into a w plus 3. So this is flip over the y-axis, but this is not shift to the right 3. This is shift left 3. Okay, so if I flip upside down and then across and shift to the left 3, it's going to push it at least partway back into quadrant 3. So quadrants 3 and 4, I think, is what I'm going to need. 2, 4, -2, -4. Okay, so if we flip both ways, the open circle we'll flip down and then across. It doesn't matter which order, you'll end up in the same spot. So we're at 1, -3, and then we move left, 1, 2, 3. So we're at -2, -3. 1, 2, 3. Open circle at -2, -3. First corner is at -2, 1. So when we flip and flip, we're going to end up at 2, -1. And then left, 1, 2, 3. So -1, -1 is our first corner. Next corner, -3, 2. When I flip and flip, ends up at 3, -2. And then 1, 2, 3 ends up at 0, -2. Okay. Last corner is at -4, 1. So when I flip, it ends up at 4, -1. And then I shift 1, 2, 3. So it ends up at 1, -1. And then finally, the closed circle is at -5, 3. So it's going to end up, when I do both flips, at 5, -3. And then 1, 2, 3. So 2, -3. 2, -3, closed circle. So it's upside down. It looks like an M now. And it's flipped left to right, so the open and closed circles are switched sides. And then we also shifted it back a little bit because just the flips would land us in quadrant 4, so it shifted back a little into quadrant 3. Okay, the next one I can see right now has a typo. So for starters, let's make this 1/3 W of x over 3. What do I want to do? Let's do -4. Okay, so the 1/3 is a vertical compression. It's outside the function, so it's affecting y's. If you multiply your y's by 1/3, this will be really short. Okay, so now we have it scrunched in here between 1/3 and 1. This is a horizontal stretch. Okay, so now it's 3 times as wide. So it's moved a little ways from the y-axis. It's very wide and it's very short. And then I need to shift down 4. Okay, so very wide, sticking a long ways out into quadrant 2, and then I shift down 4. That should push it down into quadrant 3. So I'm going to give myself a lot of room in quadrant 3. I don't know how much, but hopefully that'll do it. So -2, 4, 6, 8, 10, 12, 14. Okay, let's see. So if I start with the open circle, I'm compressing vertically, so it's going to be moving from y = 3 to y = 1. I'm stretching horizontally, so it's going to move from x = 1 to x = 3. 1, 2. Okay, so here I am at 3, 1 with the open circle, and then I move down 1, 2, 3, 4. So -3, -3. It's my open circle. Next, I need to take, what am I doing? -2, 1. It's going to be -2, 1/3. And then when I stretch, it's going to be -6, 1/3. And then when I move down, it's going to be -6. Let's see. -3 2/3. Wait. 6, 1/3 -4. Yep. 1, 2, 3. -3 2/3. Okay. I think I better start writing these so I can keep this all in my head. -3, 9, -10/3. Okay. The next corner, I'm going to write this one down so I don't lose track, is at -3, 2. If we do vertical compression, it'll end up at -3, 2/3. If we do a horizontal stretch, it'll end up at -9 2/3. And then if we shift it down 4, just -10. Oh, I think I did the arithmetic wrong on the last one. -9, -10 thirds. Okay, so the last one should be at -6. Here, let's see. We started at -2, 1. Okay, so sorry guys, backtracking for just a second so I can figure out where that's really supposed to go. If we do vertical compression, it's -2 1/3. If we do horizontal stretch, it's -6 1/3. So -4, which is like subtracting 12 thirds. So it should be -6, -11 thirds. Okay, so this was -11 thirds, and then we have -9, -10 thirds. -9, so it's a little closer in. Okay, a little bit of struggle. One more corner, what is that? -4 1. -4 1. Okay, so first the compression, vertical compression makes it -4 1/3. Then the horizontal stretch makes it -12 1/3. And then if we shift it down 4, that's going to give us -12, -11 thirds. Okay. There's 12, -12, -11 thirds. Okay, last one. The closed circle is at -5, 3. So vertical stretch, we'll put it at -5 1. I'm sorry, vertical compression, we'll put it at -5 1. Horizontal stretch, we'll put it at -15 1. And then if we shift that down 4, it'll go -15, -3. So closed circle. Okay, so it's a really flattened out, really wide W. Okay, that one was a mess. Let's see, it looks like there's one more part to this. So we're done with that graph. Here is a transformation of W. We're supposed to figure out which transformations exactly were involved and then write them into the equation, the W equation, to create a formula for this that goes with this graph. Okay, so let's see. I see that it's definitely been flipped upside down, and I don't think it has also been flipped horizontally because the open circle is still on the right-hand side. So I definitely think we need a negative out in front of our W. I think that it looks taller. This one used to be too tall. This one is 4 tall. So I think we need to stretch vertically by a factor of 2. I think it's skinnier. Is that true? 1, 2, 3, 4 wide, and this one looks like it's about 2 wide. Yeah, so it's skinnier, which means we're going to have to multiply our x's by 2 as well. That's how we get horizontal compression. And then, let's see, upside down. Okay, so I think we have at least some vertical shifts. So let's see, if we flip this upside down, it would go like this. Getting too far right there. If we then stretched it vertically, it would go to -2, -4, -2, and these would all go down to -6. So around here and here. And then we could compress horizontally. Here, let me snag another color. And it would move this point into -1/2, this point into x equals -1, 1, 2, 3, This would be at -1.5, 4, so that one would end up at x equals -2. And then last one is out -5, so it should be at -2.5. Okay, so here's our skinny m. So it doesn't look like I need to shift left or right. That looks about perfect, but it does look like I need to shift up 2. It was apparently very boring when I was choosing what numbers should go in this equation. So we need to flip, stretch vertically, compress horizontally, and shift up 2. All right, thanks for watching.